So welcome everyone for another Cyber Saturday. Today we have Bleeptrack here. He's going to explain a little bit about generative art. And it's going to be kind of hybrid because she was a little bit sick, I think. But she can explain it for herself later on. So that's why we do it this way. So Bleeptrack, the floor is yours, as they say.
Thanks so much. Yeah, and thanks so much for having me. And very sorry that we had to schedule it online very spontaneously. I felt quick over the week. I had quite a event tour in the last 2 weeks going on, and I guess I caught some nasty flu stuff in between. I'm still on the way to recovery, but I think we can manage to have a very nice 1 hour still. And also, if I don't know, my webcam or something drops out, I'm also very sorry because I have reset up. This is my old PC on there. Oh, where are we? Here. This is my old PC, and I'm now on an eGPU and whatever. So it's all it's an experimental setup, but so far it's working great. So sorry if something doesn't work on the first try, maybe. So I'm super excited to today give you a little introduction on generative art. And my idea was that, like, for the first few minutes, I will show you some slides and some images and talk about some of my projects, just as a bit of inspiration on stuff that can be done. And later on, I would like do a little coding session with you on paper.js. And maybe my first question is, do we have someone in the chat or in the room who has not ever coded at all, who is very new to coding, or are we all coding novices and experts? Give me a quick heads up in the chat, maybe how we feel about that. And in the meantime, I can maybe already start my screen sharing. So we have that running. Great. All diads here, that's perfect. Just so changes a bit on how I explain stuff and also on how we, you know, like go on coding. Yeah, you're sure, because then I don't have to explain from the beginning. Done programming before. That sounds great. Okay. Yeah, I will keep a look in the chat. Keep take a nice chair, take a nice mate or another drink of your preference, and enjoy a few of my slides. So I would like to explain a bit on generative art. And generative art is, on the one hand, a very new type of art, and on the other hand, maybe an art type that is maybe older than one might think. And it came up or gained popularity when home computers became a thing, of course, when more people had the opportunity to write their own code. And also it gained another wave of popularity now with the rise of NFTs for some reason, because I guess it's a good match for make lots of money on the blockchain, but whatever. But when you take a look at generative art and take a look at the definition, it's actually even older than computers. Because the goal is to make art in some way. This can be images, this could be music, this could be texts or poems, and basically everything you would like to create. And you make this with a rule set. So I think the current definition on Wikipedia sounds something like it's art generated by an autonomous system, which of course is a correct definition, but I read another one that I even like more, and that was about it is art generated by a rule set. And that works way better for me to explain it. So you, as the artist, come up with a rule set. Let's keep in the line of creating images, because that's what we're gonna do today. So your rule set could be a very easy rule set, and let's say you will only work with straight, horizontal, or vertical lines. This could be a rule set. And this is the rule set that you stick to, and then you can create a variety of images out of that. And of course, with code, it's super nice because you can like bake your rule set into code, and then it will create automatically the art out of it. So I think this is, of course, the reason why it gained a lot of popularity with computers. And you can feed a lot of different stuff into it. Of course, you can use randomness in different flavors, basically. That works great. But we can also think about having interactive generative art, where the user basically generates the randomness or generates the input. Or it can also be different sensors, for example, sensor data. Basically, it can be every data you want, like that makes sense for you to feed into your artwork. So that's a nice thing to go crazy with, besides pure randomness. So the first thing, maybe you've come across that already somehow, was my project Beetlespot, or my Beetle generator. And you can also see the URL on top, beetles.bleeptrack.de. So if you, I don't know, are bored on an afternoon, feel free to create your own little bugs. And this is everything this tool can do. So it creates new images of bugs. Beetles, very stylized. And on the right-hand side, you can see all the parameters. And so basically what generative art is building a parameterized model. And if we fill in the values randomly, we get a new version. And the nice thing you can also do is change the parameters, the current settings, a teeny tiny bit. And then you can very easily make animations, for example. And people sometimes ask me why the heck bugs? And this was one of these ideas you have at 2 in the morning at night in bed when you can't sleep for some reason. And I saw a nice talk from Kate Compton on generative art and procedural generation, and found this so cool and interesting that I thought, I want to do this myself. And I don't know, like bugs just came to my mind because they're very easy to recognize from their shape. They can have nice patterns and cool colors. And also, like bug is the pun with the coding error, of course. And if you take a closer look at these bugs here, you can see that they are basically built from very simple geometric shapes. You so have ellipses or circles. The feet are rectangles and triangles, and the patterns and the wings are basically Bezier curves or some sort of curve. And this is also what we will work later with. So basic geometric shapes are the go-to material to build generative art. And then I also enjoy a lot to bring generative artworks somehow in the physical world, to the physical world. And the very cool thing are pen plotters. And this is the one that you can see here is an older pen plotter. That's one of the Roland plotters. I'm not sure, maybe your Hackspace even has one, because I think they became way more popular in the last few years to regain one from Craigslist or used one somewhere. And they are really awesome. They are still crazy precise, and from my understanding, still crazy expensive. So in euros, I think most of them are around still 300 euros or something, and they are like stuff from the 80s, and they were quite common. And as you can see, like these ones, they need a special pen, and they can also be parked. Like if you take a look on the very left top corner, you can see the 1, 2, 3 numbered slots. So this pen plotter can even park the pen and take out another one in a different color. And my most loved feature on this pen plotter is the electrostatic bed. So there's a little button on the side that we currently can't see. And if you press it, the electrostatic field goes on, and then the paper just sticks to the plotter. And that's crazy awesome feature. I really missed this on modern plotters. But as you can see, like this is the modern version. This is an Axie draw, but you can also like build them yourself quite easily, I guess. And they have the pro side that you can just plug in every pencil or pen or brush or whatever you want. So there's no constraint on that. And the project that you can see here is called Overflower. So it creates flower-like petal shapes that are also inspired a bit by succulents maybe, or mandala. So it is filled with different sorts of geometric patterns. And what you, I think, can really well see in this image is what I find most interesting in generative art. So of course, your goal is to generate this variety of images, but you have to find basically the golden middle point on a spectrum that you are on. And the spectrum has 2 extreme ends. One extreme end would be over-defining. So your rule set is so precisely defined that the variety is gone. There can only be one solution to your rules. And this is one image, and this makes it a bit boring because then there's not much sense in having it generative. And the other extreme on the spectrum would be underdefining. So imagine you have basically everything is just on random. So you end up with a gray, mushy mess, I guess. So this is not exciting to look at. Everything is just weird randomness. And so you want to find the very nice spot in the middle where it's interesting to look at each image on its own, but also the variety is interesting. And you can see that all these images here, for example, they belong together, they look similar, but each one in its own is also interesting to look at. So this is a bit the thing to keep in mind when you fiddle around with parameters on your model. And other stuff you can use as a rule set basically is, of course, simulation. So a few years ago, I stumbled upon a paper that describes vein growth in leaves. And now it's autumn. Now it's autumn, and I guess, like these leaf skeletons are lying around. You can only see this cool pattern. And I enjoyed this so much that I thought this would be a great setup to make a chair out of it. So instead of growing it in this leaf shape, I grew it in a rectangle. And then you can see these same shapes emerging, but in a rectangle. So I milled this out from my DIY CNC machine. It is a very wobbly machine, and you should not let it run unattended. And it took forever. I think this piece took about 5 hours to mill, and I needed it twice. So it's the backrest and the seat basically out of this pattern. But I think it came out quite nice. I had this with me on Chaos Communication Camp in 2019, and I really enjoyed using it. But the problem is, if you make something and you are an artist and you want to enjoy your creation, it might end up in your museum. And then you are for 4 months not able to use it. This was a bit sad. So here it was an exhibition at Museum Ulm from November 19 to I think February 20. So shortly before Corona. I was very lucky with that one. It was an exhibition, but afterwards I had a nice summer in my garden. And at first I also wanted to make the feet out of this pattern. But problem is it's a bit hard to control how this pattern actually grows. And as you can see, the feet would have become very bendy. This can be a feature that you are intending to have, like office chairs, they often bend a bit backwards. But this felt so unstable for me that I scrapped the idea and just made the feet out of regular plain wood slides. And also a thing that I underestimated a lot is that I had to sand everything down by hand. And if you choose a pattern that basically maximizes the surface, you have a maximized surface to sand down by hand. And this also took forever. And I recently had to redo it for another exhibition and oil the chair up again. So cannot recommend, but if you, I don't know, at your lab have a very nice CNC machine, you can find the files on my website. So feel free to build your own one if you want to, but be aware it might take quite a long time. And another material that I enjoyed using are PCBs, for example. So a few years ago, I wanted to learn how PCB design in all, how the whole process goes, because that's a thing that I never learned at university for some reason. This was never part of my curriculum. And I thought, well, why not make it generative? And the idea was to make a little PCB that acted as a keyboard with, let's say, 3 buttons. And you can program it like an Arduino, and that's it. And so I came up with this generator first. So I generated shapes of planets and swirls and a rocket and some stars. And I put this into KiCad. And that's the first rendering that I made out of that. And the idea is, for example, that some of these stars can be shined through by light, so there's no copper at all. And in some places, I leave copper just for the aesthetics, basically. And I ordered a few of these, and I think they turned out really nice. So you can program them not only with Arduino, but also with CircuitPython, which I really enjoy nowadays. I find this way more convenient, to be honest. And the planets act as capacitive touch buttons. And then you come to the interesting point where you are also generating functional parts. So these are then also constraints that you have to have in your head when you are creating your rule set and your model. And for example, in this case, I let them manufacture. So there's also manufacturing constraints, like I don't want to become it too expensive. And this is why all the functional parts are on the very top. So the stencil doesn't change for the whole PCB, and they can reuse the same stencil. So that makes it slightly cheaper at least. And yeah, these are all considerations that then come into the generation process. And here, here's an example where you can see that some of these stars are just the fiber core center, basically. So light shines through them very nicely. And you can also see the copper that stays below the solder mask just for the swirls to give this relief structure, and also changes slightly on the blue solder mask color. And I mean, this is nothing new for you, I guess, but the community on electronics design and badges and badge life, they are super nice. And there's also like PCB art as a hashtag. So if you're interested into these topics, I can highly recommend searching for PCB art, let's say on, I guess, on Twitter, Instagram, and I guess also Mastodon, of course. Where you can find tons of awesome projects that go into this direction, maybe not necessarily generative, but overall on making cool PCBs. There's a lot of stuff to explore, very super interesting topic. And another way to, to reuse or publish your generative art could be a Twitter bot, for example, or nowadays, of course, a Mastodon bot, now that Twitter is maybe getting less and less the space some people want to hang out. And a few years ago, also Twitter changed this API. I'm not sure if you can remember, this was around the time where there was a lot of discussions on Twitter bots influencing votes in the US, for example. And this was the time when a lot of people also migrated to Mastodon. And there's a whole instance just for artsy bots, which is called bots in .space. So if you want to publish something, this is maybe the place you want to go. That's super nice. And so Beetlespot, for example, lives both on Mastodon and Twitter, and it posts a new pic every about 6 hours. And I find this a very cool and convenient way to consume generative art, because like you just subscribe and you get new pictures every few hours, and you don't have to do anything for it. It just floods your feed in a way. And it's also nice for you as the creator to watch your stuff going on, because you can observe people interacting with it. And also you don't always have to press the generate button. You can just, you know, enjoy it in an automatic fashion, basically. So this is a thing that I can really recommend to make out of your generative art pieces. And of course, activism or a community feeling can be much enhanced with generative art. So you might have seen from 35C3, the generator that I made out of Stella's very great Congress design. And this was very unexpected for me at first, because this was just a fun project for me. But in the end, so many people from the hacker community used it. This was super exciting for me to see how well accepted it was and how much joy it brought to people, because like in hindsight, it's a bit obvious, but it enables people to better participate in the community, because you can easily like make your own marks, wear the matching shirt, print posters like in a button press, and don't have to fiddle with the whole design yourself. And I guess you've then also seen on 36C3 the logo generator, and of course now at May Contain Hackers, where we also had a generative design. And I think this brings a lot of joy to events and is very nice to do. And I hope we have a lot more hacker events with generative designs in a way. And later for this one in Berlin, we had a demonstration on Article 13 going on, and people even made their demonstration signs in this style. And I was very honored to see this. And at first I wasn't even sure if it was inspired by the generator or maybe by the whole design, but I could have a talk later to the person with the sign, and he told me that yes, it was inspired by the generator. So I'm very honored to be the inspiration of a demonstration sign. Very, very awesome, very cool. And last year, I used generative art in another way to express my anger and be a bit active in a way. So we had in South Germany, in Bavaria, we had how to say, we were promised artist help funds during Corona, and they were, because the help funds, they were always rather problematic. If you're interested in that, we can talk about this later maybe. And this one actually had a very nice description on who could apply. But the problem was they promised it, and then it took 6 and 7 months, and just nothing happened. You couldn't even apply. There was no information. And I really got angry about this. And I made a little video, and this is one of the the stills from this video where I hold up this white paper. And at first you can't really see what's on it, but if you take a very close look, you can very well see my anger, I guess. So I took my pen plotter and plotted like a bunch of thousands very angry middle fingers. And if you have a bad day, feel free to make your own very angry middle fingers. I currently use these more to protest against NFTs, which also fits very well. And maybe interesting thing is like after these 6 months, the application opened and I applied, and then I got a phone call that I was chosen as one, like they chose 10 people to come to Munich and shake hands with the arts minister on this help fund, which now suddenly was how to say, stipendium and scholarship, suddenly became a scholarship for some reason. It was very weird. And I thought, oh, well, I might just bring a few flyers with me that had the stickers in it, and explained a bit on why it maybe sucks to let people wait 6 months to apply for a help fund, which suddenly became a scholarship for some reason. And yeah, so I had to shake hands and became this weird document, and had the opportunity to give out some of these flyers. Sadly, there was not much press, I guess, still because of Corona, and maybe they didn't want to have press there, I don't know, but I tried to give out as many flyers and stickers as possible on that day. Oh well. And yeah, when we come to the next thing on different data you can feed into, I have this installation, for example, which uses a webcam on top and a bit of machine learning magic. So there's M5.js running that does pose detection. So the webcam just needs to see a person, and you can detect and guess the pose of the person standing in front of that. And this is actually a very new and cool thing that you can utilize machine learning for this, because a few years prior you would have need to bought certain types of hardware, like a Kinect, for example. Or if you wanted to detect fingers, you would have bought a Leap Motion or something. And now you can all do this all with webcams. This makes it way easier and way cheaper, because you can just buy a 10 euro webcam and it works perfectly. And in this case, that's the thing that you've seen, and I'm a bit too slow to talk about it, but you've seen these plants, right? And they are in front of our Hackspace Fish Warehouse, or they were in front. We are currently a bit in a fight with Ulm City on our Hackspace, a whole different other story. But there are very cool sensors in this plant bed, some that detect humidity and sunshine and temperature. And there's one that detects basically the water suction force in the soil. This is also quite funky. And I take all of these infos and sensor data, and they influence the image that you can see here. So the pose is one of the main influences, and then color and growth speed and a bit of the way these swirls are generated are the other big factors on how this artwork comes to life. So each visitor in the museum will have a different experience when they come, depending on the day and what they do. It's called plant-human interface, and that's also a very nice thing to try out. And so coming to an end, I have 2 different projects that I want to show you. They are from this year. This one generates stamps, and these stamps work on basically on structured tiles. This might be a thing you know. So structured tiles are tiles that can interface each other, but they have different sorts of patterns on it. So it's a bit like dominoes, maybe, in a sense. So you can like attach them and make new buildings out of that, so they fit together in a way. And I made a generator that is inspired by Celtic knots and Art Nouveau swirls, basically, and makes these patterns. And they have a triangle shape, so each set, they become stamps. So each stamp set has one stamp which interfaces 3 sides, one which interfaces 2 sides, and one which interfaces only 1 side. So you have a variety to play with. And yeah, I just threw them on my laser cutter with laser cutting rubber, which is a big mess. Turns out, like, it's super dusty. I'm not sure if there's better material. And I even bought the premium one, and it's still crazy dusty if you laser cut this. But I mean, the stems themselves, they work very nicely. And I'm very proud of myself because I did not forget to mirror the top side of the stems, because of course you have to flip it so it matches, right? That's the thing that I usually forget. This time not. This time I thought about it. And yeah, as you can see, like, you can, of course, then generate different tile sets. Like, the tile sets itself, they match, but they don't necessarily match each other. So the interfacing changes also generatively. And then it's very nice to give this to people to stamp their own patterns, because you have this meta level of generativeness, because the stamps are generatively created procedurally. And the stamping new patterns and arranging them in different ways is also a generative process, because the stamps basically are the rule set, and then you can make out your own patterns out of that. So this is a thing that I find very nice and interesting to see. And they are a lot of fun. I sent them out I think, at the beginning of the year to my Patreons. They were the second last Patreon present I did. And the last thing is a current project that is called Parameter Space. So I always wanted to make something 3D that, yes, more or less, yeah, something 3D. And I started coding around in Blender and thought on 3D printing first, but this somehow got scrapped. And then I had a laser cutter I could play with, so I ended up doing something with the laser cutter. And so here I generate this asteroid shape, which has flat surfaces, a lot of flat surfaces. And on the top left, you can see shapes that I also directly generate with code. And they basically are the puzzle pieces. And then you can assemble it into a 3D wooden sculpture thingy. It looks like this. And I was crazy happy when I successfully assembled this the first time, because it took me, I think, 5 or 6 tries, and I had some calculation errors from the 3D QB thing to the 2D projection. I messed up quite a lot. And this time it sort of worked. I'm not sure if you can see my mouse pointer, but there's still a bit of a thing off here. I fixed this in the meantime, so it's perfect now. And yeah, I'm super happy with that. And I made a kinetic sculpture out of that. So this is the base structure. And I covered each of these faces with fabric and then attached a little string that goes into the center of this QB thing. And so the fabric is stretchy, and you can pull the string so the fabric goes inwards. And I attached these to 2 different servo motors, so these can pull on the strings a bit. And the idea was to have it move or breathe basically when electronic devices are around. And it looks a bit like this. I think the movement is very subtle. could be more movement. And yeah, but I mean, there's room for improvement. But the library that I use for detecting is from Pax Counter. It's called libpax. So basically, it's an ESP32 that scans for Wi-Fi and Bluetooth, and then I can take the number of found devices and use it to pull more or less on the strings. And yeah, this is something that I currently now and then fiddle with. And this is all the stuff I wanted to show. So there's a lot of different things. I hope you got a bit inspired on, different materials to use and overall shapes you can go with. And if you want to take a second look at the slides, you can find them at art.bleeptrack.de. And of course, you can just message me at Bleeptrack on basically every social media site. So now we have a bit of time left. And as you've seen, I mainly use vector graphics for my work, because I like to throw it on different sorts of machines. And this is also why today I'd like to introduce you to paper.js. So I will just close my presentation, search my mouse, and then we can go together. If you want to, you can either code along or just watch, whatever you prefer. Let's see, paper.js.org. This is where we want to go now. And you should end up at this side, and I will, I guess, zoom in a bit, because otherwise it might be a bit too tiny. All right, already have the page open. That's awesome. So we have two hide maybe. So we have two, first, this is interactive and wobbly, and this is already fun, but we have two important links here on the left side. So first thing is reference, which you might have guessed, it's the reference. So if you want to take a peek on stuff and how it works, this is your way to go. But our main goal is sketch. And you should end up at a page like this. If you have coded in paper.js before, you might end up at your own code, old code maybe. So this is where we want to be. I also zoom in a bit, I guess. So if it's too small, let me know in the chat. So we have three areas that are important. And oh, by the way, if you have a Chrome installed, maybe choose Chrome, because for Firefox, I found that sometimes the output, the error output is not going well for some reason. Or open up the developer console if you end up with an error. Just so you know, Chrome has the tendency to work slightly better here. And so we have three areas, like here goes the code. Left side is our canvas where we draw on. On the bottom, we have our console. And I think let's just get started and we make our first shape. And I suggest a rectangle maybe. So let's make a rectangle. And with vector graphics, we always work with paths. And paths are basically our main objects, and they have different attributes on styling, rotation, whatever. So the path class has a lot of predefined attributes. And if you've ever used Inkscape, for example, a lot of these things will be very familiar to you. So predefined one would be rectangle. And a rectangle needs two different things. It needs a position where it goes to, and it needs a size. And one thing is a bit unintuitive. I will show you in a moment. So first thing is the point where we want to go. And let's say we go to point, I don't know, 100, 100 maybe. And we need a size. And let's say we make it a size 50, 50. And if you want to run the code, just press the play button. If I do this now, nothing happens. This is a bit sad, but also maybe we have a quick idea on what is happening. So we have actually made a rectangle, but the rectangle does not know how it should look like. So we need to give it a bit more information on the colors. So let's see. Let's say we want to fill it. We have a fill color. And the nice thing with paper.js is we can use the HTML colors. I'm not sure if you have had to do something with web development. If you have, this will come very naturally to you. So a lot of colors for web dev have basically predefined names. So every standard color name should work. Let's say red, for example. If I press play, I have a little red rectangle here. But you can also, if you want to see more colors, you can either check out the HTML color palette for the names, or you can, of course, make your own color object with RGB values. Oh, and this is a weird thing. I forgot new and it still works. Never really found out why, but yeah, sorry for that. And we can now look at the one unintuitive thing that I find needs a quick moment to just realize. So you can click on the object and you will, which helps you a bit to do visual debugging basically. So we have our rectangle and you can see the position, and this is not the position we gave on the initialization here. And the reason is when we make the rectangle this way, it always takes the top left corner for the position basically. But overall, objects in paper.js always have the center point as their actual position. So this, yeah, like this is more on the typical, I don't know, if you come from CAD, from CAD, you might be used to having the top left corner pinned and then drawing up the size. So this is how it works basically. But the overall center point is, like the overall position is always the center point. So let's have a look at other stuff that we can style. So for example, we can have a stroke color, and I make this black maybe. So you can very slightly see that it became a red line on the outside. And we can make this bigger with the red stroke width, for example. So let's make it very big. Let's hit it to a 10. So now it becomes very thick. And these are the basic styling things that you can do. So you always have, you will always have a stroke that you can give a width and a color, and you can always give it a fill color. And paths in vector graphics, they can be closed like this one, but they can also be open, as in just a Bezier curve, for example. Then it's open. It can also have a fill color then. So these are the basic styling things that we can go with. We can also change it up a bit and say we want to scale it or rotate it. And with paper.js, everything is named very intuitively, I would say. So rotating just has the rotate function, and we give it a not radiant, a degree. We give it a degree. And for scaling, we have scale, and these are decimal percentages basically. So 1 doesn't change at all. If I take it to 2, it doubles in size. If I take it to a half, we shrink it half the size. And I think this is something where we can work a lot with already. So my suggestion would be, let's say, rotate later. Let's maybe make it medium thick. And yeah, that's fine for now. So I would say let's make grid out of these rectangles so we can play a bit with different rotations and different colors maybe. So let's make a quick for loop. Oh man, live coding is always so embarrassing because you mistype so much stuff. Yeah, let's say let's give us a number maybe on how many rectangles we want to have in our grid. I go with 5 for now. And here we go. So let's cut this in. Okay, so now we have a for loop going from 0 to 4. So we want to have 5 rectangles in the end. So if I press play now, of course, nothing happens because we draw all of these rectangles on top of each other. So we need to figure out a bit on the placement. So let's see. 100 is maybe a bit, maybe we can try 100 is maybe a bit big. Let's just say 100 times I. So we start at 0, then we have 100, 200, and so on. So this might be a bit big. Yeah, but it's actually not that bad, right? So we have them going to the right side. And now we want to basically copy these things or draw, not copying, but we want to also draw multiple of these lines below each other. So we take another for loop. Let's call it J. We might get confused on I and J, maybe, we will see. And cut that in. So now we can have 100 times I, and we can have 100 times J, and then we should see something go below. That's always nice. So now we have already a grid, which is really cool. And now a trick maybe. So when we want to center everything, we have a view object, and this view object has a center. But to do this properly, I would say we should group these elements and then center them. So I will make a group. Group is new group. And this group just needs to get the stuff added, and then we can use it as a whole object similar to all other objects. So I say group.add child. And just throw our rectangle in there. And then we can say group position is view. And let's see, I think view center does not work, I guess. Oh, it does actually. Okay, perfect. So now everything is thrown into one group. It's one big group. and it's centered. So the view object is very nice to see the size of your current canvas. Also, if you make web stuff out of it, you can see how big users have drawn it up. So that's very helpful in a lot of times. So I mean, now we have a bunch of red squares. That's a nice start. But let's get funky, I would say. So instead of red, we can make a first generated thing in a way. So the color class has neatly for us a random function that gives us a random color, which is nice. So now we can randomize the color. So each time I press play, we have a different thing. This is already very nice. It reminds me a bit of these, do you know these color cards that you show when you start filming and you can do color correction? Looks a bit like that. All right. First, that's nice, but let's maybe change a bit more stuff. So we could, what could we do? We could scale them, for example, when they grow to the right, let's say. So when I say scale, when I put the I in here, I mean they scale in a crazy big amount, but let's see. So yeah, I mean, not bad. So first thing we realize is that we start with 0, which kills the object basically because we scale to 0, and then we scale up to 4, which is very big. Not bad, but let's first hit our +1 so that we actually start at 1. So we don't lose our first column. That's nice. But then, of course, we don't maybe want to scale that much. So let's divide it by, I don't know. But yeah, by what do we want to divide by number? Is this nice? This is actually not bad, right? You can play a bit around with the numbers here, but I think this is something that we can work with, I guess. That's nice. So scaling is good. Another thing that we can do, we already had a rotation thing, so we could, I don't know, let them rotate more the more they go to the bottom, for example, and say rotate. What do we want to do? Let's see. We have our J, and of course, I mean, this does not do much because we only end up with a rotation of 4 degrees. That's not much. We could crank this up a bit to 10, so we have 40 degrees. That is, I think, actually quite nice. And now we can think of maybe having it in a randomness range, basically. So 40 is nice to be with, but let's see what could be also nice. Maybe 3 times 4 is 12 is also not bad for the end. So yeah, I think that's a nice range. So let's maybe go here J times and then a random number between 3 and 10, for example. So in JavaScript, if you need a random number, you say math random, and it gives you a random number between 0 and 1. So you need to fiddle around to get the right range. So our range size is 7. So I say times 7 and then say +3. So when this goes 0, we have 0 times 3 is 3. And if this goes full up, it won't never go to fully 7, but close to 7. +3 is our 10 that we want to have. So this sounds great. And then we might need to do brackets to make this correct. Let's see how this looks. So each time I let it run now, we have a bit of a different rotation. I think this is actually really nice. You can see the one thing is that now, because the rotation differs a bit, it jumps a bit because the center point slightly changes because of the rotation, you know. So don't worry about that. But that's nice. But I think now we have still this very random color going on here. So my idea would be to have a sort of gradient maybe. So I think we can choose 2 random colors. And then basically we do a vector math. So we have these 2 points in color space, and then we slowly walk from one point to the other through color space. And this gives us a gradient. So let's say we have our first color is a random color. And we have our second color that is also a random color. Color random. All right. So, and then maybe I want to calculate the step size for each of these, like the vector size basically, or the vector, not even the size. I call this color step, I think, yes. And this could be, so first I need the vector from one point to the other one. So it's color 2 minus color 1. And this is now a very cool thing with paper.js because it does very convenient operator overloading. So as you can see, I can subtract objects. This is very convenient because they're interpreted as a vector, and then you can very nicely do vector math. And I enjoy this a lot. It makes it way more readable. Only sad thing is basically this only works if you go with paper script. This is what we currently do. If you want to integrate paper.js code into regular JavaScript, the operator overloading does not work, sadly. But in this editor here, it does. So this is very convenient. So this is our vector from point A to point B, from color 1 to color 2. Then I can just divide it by the amount of steps I want to take. So we have five rectangles. So let's say we want to have 5 steps maybe. And then instead of the random color here, I would have my color 1 plus my color step times. And now it depends in which direction we want to go. Let's first try with I maybe. And this is already neat, I think. And as you can see, it makes a nice gradient. What would even look nicer, I would say, is to have a gradient not going from one direction, because this is already what we did with the scale and rotation, but we could have a gradient that goes diagonally, for example. And for this, I think we need to calculate maybe a bit more. Let's see if my slightly ill brain can get this done in the last 10 minutes. Maybe you need to help me a bit. So we want to get the gradient going from here to here, for example. So we have more steps, right? So we have 1, 2, 3, 4, 5, and then 4 more. So it's always n plus like 2 times the number minus 1, right? Yeah, 9 steps exactly. Thanks, friends. So it's number times 2 minus 1. So we have more steps. That's nice. So now comes the interesting part. So what do we need to do here? We have times I, and I guess plus j. Is this right? Oh yes, Franz. Franz is on fire. Look at this. Oh yes, thanks so much for helping me. That was way quicker than I thought. Amazing. Look at that. It was really nice. The thing that you could do that I think would make it way more interesting to look is to check if the colors are maybe on different sides of the color wheel, for example, because now it can happen that you choose colors that are very close together and then there's no nice gradient. So this is a thing that could be easily fixed up, I guess, to just, you know, make sure that the colors are separate in a certain distance. And also, I think when the colors get too dark, this might not look super cool. But yeah, I think that's a very nice basic thing. So that's awesome. Okay, so we have not that much time left. So what I would like to do now is I will take this link here. This contains all your code. This is super nice with paper.js. You can just share the URL with other people. Only problem is the URLs get crazy long. So let's see if Big Blue Button allows me to post this. Oh yes, that looks great. So in case you did not code along, you have the link here. And then you are basically on the exact spot that I am. So also feel free, if you have coded now something super cool and crazy, feel free to drop yours in the chat. We can either have a look And let's see, or my mouse cursor. Oh yes, look at that. This also just happened. Oh wow. This is also nice. Does it do, is there a randomness in it? Or is it, oh no, it's basically, so it doesn't change when I calculate it more times. Wow, look at that. So it basically contains of a scaled rectangle that changes color over time. Very nice. Super awesome. Yeah, feel free to share yours if you do something cool. And for the, I don't know, remaining few minutes, I don't know, maybe you have questions. We can go into questions. We can try something different. Tell me, how are you feeling? I can see messages pop up. Let's see, no questions here. That's good. Oh, we have another version. Oh yeah, let's take a look at this one. Whoops, here we go. Oh yes, this is also reading. Oops, oh yeah, I zoomed out a bit. Whoop, here we go. Look at that, very nice. Oh yes, you can very nicely see that the rotation changes here from a negative to a positive. That makes a very nice texture effect on this whole square. Awesome, well done. Love it. So yeah, like time is not huge, but a thing that I think is also very cool to show would be, now we did, yeah, like a regular randomized thing, but you can also very quickly do interactive stuff. And this is maybe to just give you for today that you can do a mouse interaction also very nicely with paper.js. So I don't think we have time to code a lot, but just so you know, you need to make a function that's called on mouse down, for example. And let's just see how this works. I will make a console log on the event so we can peek into that event. All right. And then there's one thing to know, because this is a bit tricky. There's now two cursors. As soon as you start with mouse stuff, you will get another cursor. So this is still the debugging cursor, let's call it. And then you have the drawing cursor, which actually triggers the mouse inputs. This is a little pit that I fell into recently. So when I click, you can see we get interesting things. And aha, it was a mouse down event. We get the point, and we also get the count. And this is a thing that is very nice, because you can super easily count how often it has been clicked, for example. And so you can very quickly say, okay, let's make a circle. And yeah, Dave just said it's a very great tool to give a coding introduction. I think so too. I think like coding visual stuff or coding Arduinos are very nice tools to get people into coding, because it's way more rewarding than just a regular Hello World or something. And so what I currently do is I can make a circle on where I clicked. Event point is where I clicked, and count. Oh yes, yeah, event count gives me the amounts of times I've clicked, and so it will make bigger circles every time I click. So, and I also maybe wanted to have like a minimal size of, let's say, 5. And then I can just say circle fill color is color random, for example. And now I already have a nice interactive clicky thing where the circles grow each time I click. And a thing that I really enjoyed doing with a group of people from theater last time was to make basically something like a spiralograph. Do you know these things? Where we had a circle that follows the mouse, and on this circle, the actual point that draws was moving around the circle. So you could move the mouse, but it would always make more loops around your mouse. This is a very nice thing. And just so you see it, like the mouse interaction. Oh yes, fond child memories, exactly. And just to give you an example on cool mouse interaction, maybe there's one running on my website, Bleeptrack BE, in the background, basically, that I use paper.js for. So when you click somewhere, you see like these swirls coming to your mouse, and when you click somewhere else, it will just grow to there. So this can also be fun interactive thingy. And as you can see, if other people click there, it will also move on. So there's a little socket.io thing going on where you have a shared clicking experience on my website, basically. So yeah, just for the mouse things. And when we go, mouse stuff is cool, but we can also say we want to have it animated in a way. Then there's also on frame. So each frame that gets rendered, you can call up this function. This is also very convenient. And for, let's say we save all these circles, maybe. Circle array is an empty array, and we save it in there. So circle array push circle. And we could like drop them all to the floor, let them arise. Oh yeah, let's rise them up like bubbles maybe. So I say circle array for each. I'm not sure if you code JavaScript, but this is like a streamed for loop basically. So I can say for each circle in where did we go? So for each circle that is in the circle array, I can say circle position. We only want to change the y-axis. Why? -1, right? So we go to the top. Does this work? Let's see. We get, oh no, we get errors. Oh no, I think I don't need the round brackets here. Oh yes. Oh yes. Now you can see we can make a little. Yes. We can little bubbles popping up. So it's very. Oh no, Dave's laptop has problems. In the meantime, I think some people might still hear me. I don't know. Maybe they do. I dropped the link in here. We still hear you. That's perfect. All good. So now you have an example on very easy mouse interaction in frames, and the paper.js reference also has in the tutorial section a very nice one on creating mouse tools. So this is one I can recommend a lot if you want to dig more into mouse tool stuff, because they're very nice and neat settings that can be utilized to make cool interactive drawing things actually very quickly. And I think with that, our 1 hour is also very, very close to finish. So let me know when there's questions or stuff you want to see, or otherwise, I would say let's have a nice. Oh yes, Dave is back. I can hear Dave's microphone. There's Dave. Awesome.
You can hear me now? Yeah.
I can hear you now. Perfect.
I don't know if there are any questions right here now. I think they want to play with the new learned skills here. So I think this is kind of the official part then. Yeah, thank you for the explanation and for the examples. And maybe we're going to share later on the results of today on Twitter or something like that.
Yes, of course.
And I think we can finish right now, right? maintenance. They are very busy in the programming.
I thought so. I
That's
thought
good.
so. Yes, have fun experimenting. It's a very nice playground to just stick around.
Yeah, yeah. And probably you can also make animations and stuff like that with paper.js.
Absolutely.
Cool. Thank you. And yeah, I think we're gonna post some of the nice results on the Twitter or something like that, so you can watch the products. And then we finish right now. So thank you.
Yes, awesome. Thanks for having me and enjoy coding. See ya.
Yeah. Okay. Bye bye.